Hello, everyone. Today I'm going to show you how to deploy an easy-to-use computer vision monitoring system with Groundlight AI. With Groundlight, you can ask natural language queries about images and get fast, reliable answers. This video assumes that you understand the basics of the Groundlight Python SDK and have generated a Groundlight API token. If you haven't done this yet, check out our previous video, which will show you how. The app I'm going to build today will run on Raspberry Pi 02 and use a standard webcam. You could also use a Raspberry Pi camera. There are a few accessories you'll need for this tutorial. Of course, you'll need a power supply and a micro SD card for the Raspberry Pi 02. It's also a good idea to get an HDMI adapter, USB adapter, and a case for the Raspberry Pi. I also used an adjustable mount for the webcam and some adhesive pads to attach the Raspberry Pi to my wall. You can find a list of the hardware components in the description of this video. In today's example, I'm going to monitor my parking spot, which is visible from my home office window, and send alerts when cars come and go. In this way, I'll be able to keep tabs on my spot and be alerted when someone's using it. As you follow along with this tutorial, feel free to ask Groundlight a different question. For example, you could ask, is the garage door open? And then receive alerts if it remains open for too long. Or you could ask, is there a deer in my garden? And play an alarm to scare it away. We're not going to cover how to integrate a speaker in today's tutorial, but we might talk about that in a future video. To get started, we first need to flash Raspberry Pi OS to our micro SD card. There's a tool called the Raspberry Pi Imager. So we're going to first download that if you don't already have it. Make sure you download the correct version for your OS. I'm going to get the Windows version. Okay, then run the installer, and then you'll have the application. Once you have the application open, it will look something like this. First step is to choose your OS. And today, I'm actually not going to choose any of the recommended ones here at the top. I'm going to go over to Raspberry Pi OS Other and select Raspberry Pi OS Lite 32-bit. So Lite means that it's headless, so there won't be any desktop environment. You just get a terminal. It's actually all we need for this simple app, so I like to keep it simple. I'm choosing 32-bit because in my experience, the 64-bit is a little unstable. It is faster, but it tends to consume all the available memory and then crash. So I've had a lot better luck using 32-bit. And next, you need to make sure that your micro SD card is inserted into your computer. Then click Choose Storage, select your SD card, and we're almost ready to write. But before we do that, I want to take a look at some of these settings. Okay, so the first thing you should pay attention to here is the host name. You can give it a custom host name, and this will help you SSH into it. So I'm calling mine Parkmon. That's short for Parking Monitor. That's the name of the application that we're building today. We're also going to enable SSH. That allows us to network into the device and do things on it directly from our laptop. I like to select the option here that says Allow Public Key Authentication Only. So that means only users with the SSH key can get in. The password is not sufficient. So that's just a little bit more secure to do it that way. Next, you should set up a username and password for the Raspberry Pi. If you're using SSH, you might not have to use this, but sometimes things go wrong with SSH and you might want to plug it into a monitor and keyboard. And when you do that, you need to log in with the username and password. Next, you're going to set up your Wi-Fi. So just put in the SSID and the password of your Wi-Fi network. And then when you're done with all that, click Save. And now we're ready to write the OS. Now that the OS is flashed, we can take the micro SD out of the laptop, put it into the Raspberry Pi, and plug it in. After a few minutes, it should come online and we can SSH into it. Let's give it a try. So we're going to run SSH pi at Parkmon. Now, when you do this for the first time, it takes a little bit of time for the Raspberry Pi to come online. So be patient. Don't give up right away. Give it 5 or 10 minutes. And if that still doesn't work, you can try plugging it into a monitor and keyboard and seeing what's going on. Okay, there we go. The first time this successfully connects, you'll get a message like this. Just answer yes to it. And we're in. Now that we've successfully connected to our Raspberry Pi, we can unplug it and deploy it on site. In my case, I'm going to put it next to my window and attach a USB webcam pointed outside the window. And once it comes back online, just SSH in one more time. And now it's time to start setting up our project on the Raspberry Pi. The first thing I'd like to do is create a folder for it called Parkmon. And we're going to go into that folder. And just like the last video, we're going to set up a virtual Python environment to hold our packages. So we'll do that by running python 3-m venv, and then we give a name to the environment. We'll call this one pm_env. Okay, it looks like the environment was created. Now let's activate it by running source pm_env bin activate. Okay, so now we're in the environment. Next, we're going to install OpenCV, which we'll use in this project. This can be a little bit difficult on Raspberry Pi 02. If you do it the normal way, just pip install OpenCV Python, that's probably not going to work. It's going to go on forever and maybe not complete. And that's because this Raspberry Pi is a little resource constrained, and this is a really big package. And then similarly, if you try to install FrameGrab, well, FrameGrab has OpenCV as a dependency, and you're going to run into the same issue. So I'm going to show you a convenient way to get around this problem. We are going to install OpenCV from a pre-built wheel available on piwheels.org. So don't worry about typing out this command here. We're going to put this in the description of the video so you can copy and paste. But go ahead and run that, and that will download the wheel for you, and it shouldn't take too long. Okay, so we've got the wheel. So now we need to use pip install to install the wheel. Again, here's another command that you can copy and paste. And this should also be relatively fast. Okay, so OpenCV has finished installing for me. That took less than a minute on my machine. Now we're going to install some other dependencies that we need. And just like the last video, we're going to pip install Groundlight and FrameGrab. So the installation of Groundlight and FrameGrab has completed. Okay, there's one more issue we need to take care of, and that is our version of NumPy. You may run into issues with your version of NumPy not being compatible with the version of OpenCV that we got from that pre-built wheel. So just to make sure that won't cause you any problems, we're going to first uninstall NumPy and then install a particular version of it. So let's start by running pip uninstall NumPy. Okay, then we're going to do pip install NumPy. The version we want is 1.26.4. That's been working well for me. So let's run that. Okay, now we've got the right version of NumPy, and we are done installing dependencies. Next, we need to make sure that our Raspberry Pi is authenticated with Groundlight. So we're going to need our Groundlight API token that we generated in the previous video. If you don't still have that, you can go generate a new one. And in this video, I want to do something a little bit more sophisticated. We're actually going to put it into a file rather than just exporting it once. So what you can do is you can echo this string into a file. Okay, and then here, go retrieve your API token. It should be in a password manager or something like that, and then paste it in. Now we're going to put this into a file called .env_secrets. And there we go. And next, I like to source this in my bash RC so that every time I open a terminal on my Raspberry Pi, it has this credential in there. So what we're going to do is open our bash RC with a text editor. I'll use Nano. And then I like to come down here to the bottom and source. You need to know the full path of that file, which should be like this. All right. So let's test it out here. We can echo our Groundlight API token. It's not there because we haven't sourced our bash RC yet. And there it is. So that credential will always be available for us now. Now it's time for the fun part. We've finished all of the setup and installation, and we can actually write some code. Usually what I like to do is go into VS Code and connect with SSH to the Raspberry Pi, and you can code directly from your laptop. So to do that, look for the button here in the bottom left corner that says Open a Remote Window. Then you're going to select Connect to Host. Okay, and then you select Add New SSH Host, and you're just going to SSH in like you've done before. And VS Code will help you get all this set up and configured. And it's going to ask you which SSH configuration file you want to update. The first one shown here is the one that's typically used, so we'll just go with that. And it says host added. You can open up the configuration file and see that it took care of that for you. And then I think you need to attempt this one more time. So go back and connect to host. Now you see that Parkmon is an option. You can select that, and it will SSH in. The first time it does this, it'll take a bit of time installing VS Code Server on the Raspberry Pi, so give it a few minutes to do that. But it will be faster the next time you do it. So now VS Code has connected with SSH to the Raspberry Pi. If you look in the bottom left corner, it should say SSH Parkmon. Now I like to come up here to the Explorer and open a folder. And you'll see there's already a Parkmon folder on the Raspberry Pi. Remember, we created that earlier. So let's open that up. That's where all of our project files are going to live. Let's create a file called app.py, and we'll put all of the code for our application in here. We're going to start by doing some imports. So first of all, from FrameGrab, we're going to import FrameGrabber. That's going to help us manage the cameras. And this time we're also going to import something called Motion Detector. And you'll see what that's all about in a bit. Of course, we're going to import Groundlight. And we're also going to get the time package, and we're going to import logging. And while we're at it, let's go ahead and set up the logger. And we'll just do this in kind of the basic Python way, logging.getLogger, and then pass in the name of the module. Now let's set up a camera. So I've already plugged in my USB webcam to my Raspberry Pi and positioned it on my window. And now I'm going to use FrameGrab to find my camera and get some details about it. So we're back in the terminal, and we're going to run FrameGrab AutoDiscover. And this will attempt to find all the cameras that are plugged in or available on the network. And then it's going to print out some information about them. There we go. So it found one generic USB camera with this serial number connected to my Raspberry Pi, and that's exactly what I expected. So I'm going to show you a little trick now. You can copy this YAML that it outputted. Just select it, copy it. Then we're going to come back to VS Code and create a new file. We're going to call that cameraconfig.yaml. And we're going to paste that YAML block into the file. And from here, if you want to, you can edit some things. So we could give it a name, call it window cam. And you can also change some of the options here. Now, if you look at the README for FrameGrab, you'll see the different options that are available. For now, I'm not going to put anything there, but I might come back later and do some zooming or cropping. So we can go ahead and close that file. And we're going to go back to our app.py and use that information to connect to the camera. So let's define a variable called YAML path. And it's just going to be that cameraconfig.yaml that we created. And then we're going to connect to the camera. We're going to call that grabber. We're going to use the FrameGrab library and a particular method called fromYAML. And all you need to do here is pass in the path to the YAML. This is going to return a list, so let's go ahead and select the first one. Okay, now we have our camera. Next, I'm going to set up our main function and create a little video loop to make sure things are working. So define a main function. And then we're going to do a while true loop in here. All right, so grabber.grab, that's going to get a frame from the camera. And then just to make sure that it worked, we'll print out the shape of the frame. Okay, let's add a little bit of delay so this doesn't go crazy. So we'll do time.sleep for 1 second. And now we need to call the main function, and we'll just do this in the normal Python way. Its name, you guys know how it goes. Okay. So we called our main function. It's going to do a little loop and just get frames and print out the shape of the frame. Let's see if that works. Okay, back in the terminal, we're going to do Python 3 app.py. Great, so it looks like our program is looping and getting frames for us. Now that we've connected to our cameras and we know that's working, let's connect to Groundlight. So just like the last video, we're going to create the Groundlight client, call it GL, and you connect to that by running groundlight.groundlight. And it's going to read from the environment variables to find your API token. So if you put it there, it should work fine. Next, we need to connect to our detector. And we're just going to call that detector. And here we're going to do something a little bit different from the last video. We're going to do gl.get detector. And this assumes that you have set up a detector and you're just going to pass in the detector ID here. So now what we need to do is go to groundlight.ai and set up a detector and copy that ID. So I've logged in at groundlight.ai. And this is a new account, so I don't have any detectors yet. I'm going to click Create New. And the name will be Parking Spot Monitor. And the question will be, is there a car in the parking spot? And I think that's all I need for right now. We'll go ahead and create that detector. All right, and then up here in the address bar, you'll see the ID for the detector. I'm going to go ahead and copy that. And we'll take that back to VS Code and put it into our application. So we're back in VS Code now. We have the detector ID that we copied from Groundlight AI, and we'll put it in right here. So there's a few more things we should add to our script now. First, I'd like to define a variable called wait time. That's basically going to be the cycle time of our application. So we're going to take that and put that into the sleep function here. Next, we're actually going to make the call to Groundlight, make an image query. So let's delete this print line. And then we're going to do gl.askAsync. And you might remember from the previous tutorial, this is a way of asking a question of Groundlight and not waiting for the answer. And the reason that we're doing that here is because our application doesn't really care about the answer. We're not going to be turning on a light or playing a sound or anything like that. We're going to let the backend notifications trigger off of the results, but our actual application won't care about the results. And I think that'll all make a bit more sense as we go through this. So all we need to do with this function is pass in the detector that we're sending this query to, and of course the actual image itself. And then you can capture the result here as an image query. So this image query won't have an answer yet. It'll just give us an ID. There is a function that you can use to come back later and pull for an answer, but we're not going to do that today. All right, that's basically it. Let's add a logging line so that we can see what's happening. We're going to do a logger.info. I will say asking Groundlight. And then you can put in the query text to the detector like that. And then just for diagnostic purposes, I'd like to put in the image query ID if we ever want to go and look that up on the back end. And then it would also be nice to put the time in here. We don't have the time yet, so let's define a new variable called now. And then we're going to use the function time.localTime. All right, so that will get us the local time in our time zone. It's not very human readable though, so I'm going to define another variable called nowString, and then we're going to use this function to convert now into a human readable string. And we can put that into our log. Let's also add a log for our sleep command here. All right, so now we're going to be able to see when we're sending a question to Groundlight and when we're sleeping and for how long we're sleeping. Okay, let's give this a try and make sure that this all works so far. All right, so we're back in our terminal and we're going to run Python 3 app.py. All right, so it appears to be working. It's asking the question, is there a car in the parking spot? We can see the image query ID and the time, and we can see that it's sleeping. Let's go ahead and stop that. All right, so I've opened my Groundlight.ai account, and what you'll notice now is our detector has an image in it, and it looks pretty good. Let's open this up, and then drill down into our total image queries, see what happened here. So what you can see here is, since this is a new detector, the algorithm answer was a very low confidence, and it escalated to some human labelers who gave us the final answer. So that's pretty neat. However, I'm going to make a little personal recommendation here. So at the beginning, sometimes I like to actually turn off the cloud labeling, and that way I can kind of babysit my detector, label images on my own, make sure I have my camera lined up, and then once things seem to be working pretty well, you can turn on cloud labelers and let it run by itself. And during this time, you can also experiment with different confidence thresholds to see what works well for your detector. All right, so I've turned off cloud labeling for this detector. Let's go back to VS Code and continue our application. So I can see from this first image that I might like to zoom in a little bit. There's a lot of extraneous information in the frame. There's other parking spots. I'd really like to get it down to just showing the one parking spot that I care about. And there's a few different options for this. You can go to the frame grab README and read through the configurations, and you'll notice that there's ways of doing crop and zoom and a few other things that might be useful. In today's example, I'm just going to apply a bit of zoom. And we're back in VS Code looking at our camera config.yaml, and this is where we can apply some options to zoom and crop our image. So what I'll do is apply some zoom, specifically digital zoom, of about 2.0. I think that's going to be right. So let's run our application one more time and find out. Here. The application is running, and we can go back to groundlight.ai to see what the images look like. So some new images have come in, and they are looking much better. Now we only see the one parking spot that we care about. All right, now we're going to set up motion detection, as I alluded to earlier. Motion detection is useful in applications like this because most of the time the scene is static, so you don't really need to be submitting image queries all the time. You only want to submit image queries when there's motion. And the frame grab library has a motion detector, and we're going to use that today. So we'll call it motion detector, and we'll call motion detector. And it's really just that simple. There is an option where you can pass in a different threshold for motion sensitivity. I actually just went with the default, and it worked really well for me. But you can experiment with that on your end and see if you need to increase it or decrease it. The default is 1% pixel change. All right, next I'm going to do something that may seem a little complicated at first, but I'm going to try to explain why I did it for this application. So in my application, I found that it was actually really useful to track not only if motion was detected in the current frame, but if it was detected in the previous frame. And then in both cases, we'll consider that to be a reason to contact Groundlight, and that way we make sure that we don't miss any important events. So I'll explain this a bit more as we go through, but let's just start by initializing some variables. So we're going to have one called motion detected, and then also motion detected previous. And both of these will be false to begin with. Okay, and then down in our main loop, we're going to check if motion was detected. All right, and it's that simple. So that's going to return true or false that motion was detected. But I said earlier we were keeping track of if motion was detected in the previous frame too. So right before we do that, we're going to do motion detected previous equals motion detected. All right, that should work. And then we're going to say if motion detected or motion detected previous. So again, that means if motion was detected in the current frame or the previous frame, we're going to interpret that as a reason to reach out to Groundlight and make an image query. And I forgot a critical thing here. When you call the motion detector, you need to give it a frame. So let me add that. All right, and then if there's no motion detected, we're just going to log that. All right, let's run this and see how it does. So we're running the application again in the terminal. So the application is running now, and it's mostly not seeing any motion for the past few iterations. And that makes sense because nothing's happening out there. But you can kind of wave your hand in front of the camera, step in front of it, and get a sense for how the motion detection works. So just to explain in a little more detail why I decided to track motion in the previous frame as well as the current frame, here is a detector that's very similar to the one I'm working on right now. And basically what this one is trying to do is track this specific white car right here in the garage and notify me when the car arrives and leaves. So you can see in the first two frames, the scene is basically the same. The car hasn't moved. There's no motion detected. So no need to even ask Groundlight what's going on because we know nothing has changed. And then in the third frame, the car has left the garage, is pulling out, going up the driveway. And that's a really big change in motion. So motion was detected. We reach out to Groundlight. We find out that, yes, the car is here. And then the problem arises in the fourth frame. So in the fourth frame, the car has already left. It's no longer visible in the frame. But the amount of motion between the third and the fourth frame was not very big. So that comes back as no motion detected. So we don't reach out to Groundlight and we don't find that the car has left. So basically we're missing an event there. So that's the reason I like to submit an image query, not only if there's motion in the current frame, but also motion in the previous frame. You may find for your application that's not really necessary. Maybe I'm overcomplicating things, but that's what has been working well in my application. The next thing I'd like to add to my application is working hours or operational hours. I don't want this thing running 24 hours a day. One, because it gets kind of dark outside, it may not be able to see anything, and I don't really care what happens at night. So we're going to define a few more variables. We're going to define a start time. For this, we're going to use time.structTime. And then the way this works is you pass in a tuple with 9 elements. So it goes year, month, day, hour. So let's have mine start at 7 a.m. And we're also going to define an end. And I decided kind of arbitrarily we'll have it stop at 9:30. Okay, next I'm going to drop in a little helper function here. I'm not going to explain this too much, but you can see that this is going to get the number of seconds since midnight. And that'll allow us to easily compare different times against each other and see which one is later. Now we're going to use that function to create some new constants. We're going to have one called start seconds. And we're going to call get seconds since midnight. And we'll pass in start. And we'll do the same thing for end. All right, so now we've converted our start and end time into seconds, and we can make easy comparisons. Okay, one more little function I'm going to drop in here. This one will tell us if the current time is within operating hours. So it's going to take the current time as struct time, convert it to seconds, do a little comparison here, and return a true or false. All right, so let's use that function now. We're going to come down here to the part of the application where we're grabbing the frame, and we're going to check if the current time is within operating hours. Actually, let's check if it's not within operating hours. This might make more sense. So if it's not within operating hours, we're just going to log something. We'll do logger.info, and we'll log the current time for traceability. And then if it's not, or if it is within operating hours, we're going to do all the things that we normally do. We're going to grab the frame, check for motion, and then reach out to Groundlight if necessary. Okay, let's give that a try. All right, so in our terminal, run the application again, and it's working now. If you're curious about how the operational hours work, you can try tweaking those values and doing some experimentation, but I'm pretty confident that it's working now. I'm going to leave my detector running for a while and capture some data. Be back in a bit. All right, so I'm back. The detector has been running for a bit of time and has collected some data. I don't think it's collected a lot of data yet because the motion detection is actually working pretty well. But I'm going to come here to my detector and click this button that says Label Image Queries, and we'll find out what it's been seeing so far. All right, so there's the car leaving. So the question is there a car in the parking spot? Yes. Another yes. And another yes. All right, and we got a no here. And I'm just going to go through each one of these and manually label them all. I don't think there's too many yet. So I've finished labeling all the image queries that have been submitted so far. And you can see that it's calculated a projected ML accuracy given the data it currently has. We can come back and check on its progress later after it's collected more data. So our application seems to be running really well now, but I want to make sure that it always runs, even if we reboot the Raspberry Pi. So in order to do that, I'm going to write a little shell script. We'll call it run parkmon.sh. And it looks like this. You can pause it right here if you want to write it out. Basically, what it's doing is it's moving into the directory of our project. We're defining a log file where we can log everything that happens. We're also sourcing this file here that contains our Groundlight API token. And then we've got a simple loop going where we run our Python application, writing anything that happens, whether it's an error or just a simple log, to our log file. And then if our script raises any exceptions at all, this script will sleep 10 seconds and restart it for us. So this will keep it going indefinitely. Now we need to make sure that the script is executable. And you can do that by running chmod +x and then the script. Great, so that is now an executable script. Now we can add this as a cron job. So let's run cron tab-e, come down to the bottom here and write @reboot, and then just the name of the script. All right, let's save that file. And now we're going to reboot the Raspberry Pi, and when it comes back up, it should start running our application. All right, the Raspberry Pi has rebooted. Now, if you remember earlier, our script is writing to a log file. So let's check out that log file and see what's happening. Great, so I see some activity in the logs here. We can use this to keep track of what's happening. At this point, I would probably leave the detector running for a bit more, maybe a few more hours, maybe even a day, and then we'll have collected some really good data. Once we have that, we can set up some alerts and also enable cloud labeling to make this thing fully automatic. So let's assume that we've now collected enough data for our detector and we'd like to really turn it on and start receiving alerts. The first thing we're going to do is turn on cloud labeling. And this way, if the ML is not able to get a sufficiently confident answer, it'll escalate to a person and get that confident answer. Next, we're going to enable some alerts so that anytime a car arrives or leaves, that'll send me a text message. To do that, we're going to click on Outputs and then click Create New Groundlight Action. This is going to be a little bit different than the previous tutorial, so I'll explain carefully what I'm doing here. The first action will send a text when a car arrives. So we'll call this car arrives, send me a text. And then the condition, instead of being returns answer, it will be changes to yes. So that means when it changes from a no answer to a yes, that'll trigger this notification. And then we can put in our phone number. Okay, let's create one more for when car leaves. All right, so again, we're going to select changes to, but this time we're selecting no, and we're putting in our phone number. All right, so those are the two notifications that I'd like to receive. So that's it for today's video. I hope everyone is able to use this code as a starting point to build some interesting applications. If you have any questions about Groundlight, feel free to reach out to us at info@groundlight.ai.